So this video is for integrated 3. This is our notes on solving 3 variable inequality. So for this, let me just jot that down. Solving 3 variable inequalities. So our goal is to get 3 equations in 3 variables down to 2 equations in 2 variables, and like we did in integrated 1, and then solve that system. So let me just write that goal. So our goal is to get 3 equations in 3 variables Okay, so 3 equations in 3 variables down to 2 equations in 2 variables. Then solve that system as we normally do. Now, when I say solve that system as you normally do, we normally will take that system and solve it using equal values, substitution, elimination. Most likely today we're going to do a lot of elimination. And we're trying to get it down to 1 equation in 1 variable. That's going to be our ultimate goal. Okay. So our first example. So example 1. And I'm going to number these equations, okay, just so I can talk about them. So let's say one of them is equation 1, one of them is equation 2, one of them is equation 3. And I'm going to zoom in a little bit more. Okay, so let's say that the first one is negative 5x plus 3y plus 2z is equal to 11. And let's say the second one is 8x minus 5y plus 2z is equal to negative 55. And let's say the third one is 4x minus 7y minus 2z is equal to a negative 29. So what we want to do is we want to look at these equations and decide, is it easiest to try to eliminate our x's, or is it easier to try to eliminate our y's, or is it easier to try to eliminate our z's? Okay, now if I was trying to eliminate our x's, I'd have to try to cancel a negative 5x and 8x and a 4x. So I'd have to try to use one of these equations to try to maybe eliminate the other ones. The x's aren't looking too good for me. My y's, a 3, a 5, and a 7, that's not going to be easy to do. But if I'm looking at, sorry, trying to get my blue. If I'm looking at my y's, not my y's, sorry, my z's, those ones to me look like that would be nice because I have a positive 2z, a positive 2z, and a negative 2z. So I can easily do this. Now, what we're going to do is we're going to use 2 of the equations at a time. We're going to use 2 equations to eliminate my z. And then I'm going to use the third equation with one of the other two to eliminate the z in that. So what I think I'm going to do is I think I'm going to take equation 1, okay? I'm going to take equation 1, and I'm going to take 1, and I'm going to take 3. So I am going to take 8x, sorry, I said 1, let me write 1. I'm going to take negative 5x plus 2y plus 2z equals 11. I'm going to take my third equation, which is 4x minus 7y minus 2z is equal to a negative 29. And I'm going to add those two equations together. And what's going to happen is my z's, my positive 2z and my negative 2z, they're going to cancel each other out. And what I'm going to get is I'm going to get a negative x minus 4y is equal to a negative 18. Now, I'm going to call this equation 4 just so I can refer back to it. Okay. Now, the next thing I'm going to do is I'm going to take equation 2 because I haven't used equation 2. So now let me take equation 2. And I'm going to use it with 3 again, because that's the easiest way to eliminate my z's. So I'm going to have 8x minus 5y plus 2z is equal to a negative 55. I'm going to have 4x minus 7y minus 2z is equal to a negative 29. I'm going to add these two equations together. And again, what's going to happen is this positive 2z and this negative 2z are going to eliminate. And I am going to end up with a 12x minus 12y is equal to a negative 84. And that is going to be, I'm going to call it equation 5 so I can refer to it. So now I'm going to take these two red equations and I'm going to use them to try to eliminate. Now, something I notice is that I can divide everything in that equation 5 by a 12. I think I can clean this up and divide by 12, divide by 12, divide by 12. And I'm going to get a new equation 5, a cleaner equation 5. This is going to be an x minus y is equal to, and when I take 12 into 84, I get a negative 7. And so now I have these two equations. So I'm going to take this equation 4 and this equation 5. And now this is the two variable system I am going to solve. Okay. So let me bring those over here. So I am going to take equation 4, which is negative x minus 4y equals a negative 18. I'm going to take my cleaned up equation 5, which is an x minus y equal a negative 7, and I'm going to solve this system. Okay, I'm going to solve it for x and y. I'm going to solve the system. I'm going to pretend like I don't have anything else but this to solve. Now, what I will notice is here, I am going to have a negative x and a positive x. So I can actually add these together. And when I add these two equations together, my x's are going to cancel out. And I'm going to end up with a negative 5y is equal to a negative 25. Divide by a negative 5, and I get that my y is 5. So I found my y. But I'm not done with this system yet, because the system had, the red system, 4 and 5, had an x. So I'm going to substitute that either into equation 4 or 5. I'm thinking 5. So I think I'm going to put it into 5. Okay, so I'm going to put that into 5. So I'm going to go x minus 5 equals a negative 7. And when I solve that, I'm going to get x equal, when I add 5, a negative 2. So I have my x and I have my y. Once I get my x and y, I can take those and put them either into equation 1, okay, this one here, or or equation 2 or equation 3. Okay, whichever one you prefer. I'm trying to find my z. I'm thinking maybe I'll do it into one that has a positive z. So it doesn't matter. Let's say I do it into equation 1. Okay, so let's say I'm going to do it into equation 1. So let me do that. So I'm going to shrink this slightly, and I'm going to take equation 1. Okay, I'm going to take equation 1, which was a negative 5x plus 3y plus 2z. I'm just going to write it so I have it here, equal 11. Okay, I'm just going to move this now, and I'm going to substitute in my y. Okay, my y here and my x here. Okay, so I'm going to get negative 5 times negative 2 plus 3 times 5 plus 2z equals 11. So I get 10 plus 15 plus 2z equals 11. So that's a 25 plus 2z equals 11. I'm going to minus 25 from both sides, and I get a negative 14. I'm going to divide by 2, and I get a negative 7. So I found my x, my y, my z. Now, these are a point in 3 dimensions. We always list our coordinates x first, then y, then z. So my final answer is going to be negative 2, comma 5, comma negative 7. That is our answer. So in this next example, what I'm going to do is, in this situation, this is still going to be 3 variables with 3 equations, but when we're doing this, we do not have 3 variables necessarily in each of the equations. Okay, so I'm going to call equation 1 2x minus y equals 5. I'm going to call equation 2 3y plus z is equal to 0. I'm going to call equation 3 x plus 4z is equal to 14. So again, each of these equations has either an x or a y or a z, a pair of them, but none of them has all 3. But it's still a system of equations with 3 equations in 3 variables. Now, in a situation like this, a lot of times people end up doing extra math. So when I solve these problems, like up here, what my goal is to eliminate one of the variables and get 2 equations with that same variable eliminated. So in example 1, I eliminated my z's. So down here, I want to decide, do I want to eliminate my z's, my x's, my y's? So when I'm looking at this, like if I'm looking at my x's, I see I have a 2x and an x. So I can multiply the third equation by a negative 2 and easily eliminate my x's. Okay. If I wanted to eliminate my y's, I can multiply the top equation by 3 and get my y's to eliminate. And if I wanted to eliminate my z's, I could multiply the middle equation, the second equation, by a negative 4 and have it eliminate with my my 4z. It doesn't matter which one. Okay, it does not matter which one. So I'm either going to eliminate my x's, my y's, or my z's. So let's say that since my y is negative, maybe I try to eliminate my y's. Okay, doesn't matter. Okay, so I can do any of them, but let's say that we want to eliminate y. So if I am eliminating my y, I am going to take equation 1, but for equation 1, I'm going to take equation 2, okay? For equation 1, which is a 2x, and actually I think I'm going to move it down here. I'm going to move it over here. Okay, I'm going to take my 2x minus y equal 5, and I am going to multiply this. I'm going to give myself some space. I'm going to multiply that by something because I want to have it cancel with the y in equation 3. So I'm thinking that I'm going to multiply this first equation by a -3. So when I do that, my equation 1 is now going to be a -6x plus 3y, and I'm going to leave myself some space for my z's, is equal to a -15. My equation 2, I'm going to keep it as is. I didn't have any x's. Oh, and sorry, I don't want to multiply it by a -3 because it was negative. I want to multiply it by a +3. I apologize. So that's going to be a +6x, a -3y, and a +15. Okay, I'm multiplying by a +3. So now when I write my second equation, it's going to be a 3y plus z is equal to 0. So now I'm going to add these two equations together. And when I add these two equations together, what happens is I'm going to get 6x, my y's canceled out, plus z is equal to 15. I'm going to call this equation 4. Okay, so I used 1 and 2. Now, the equation I did not use is equation 3. And if you look at equation 3 has x's and z's, so I don't have to eliminate. So what's going to happen in a situation like this, one of these equations is most likely going to be the one you keep, and the other two you're going to eliminate the variable that third one did not have. So if I'm thinking about keeping this one, in these other two equations, I'm eliminating the variable that this does not have, which is my y. Okay. So now my system I'm going to solve is I am going to be looking at equation 3, which is x plus 4z equal 14. My new equation 4, which is 6x plus z equal 15. And now I'm going to solve this system, just like I would back in integrated 1. So looking at this, I can either multiply the top equation by -6 to get rid of the x's, or the bottom equation by -4. So let's say I multiply the bottom equation by, and I'm just going to move these numbers out. This was equation 3, this is equation 4, and I'm going to be multiplying the bottom equation by a -4. So when I do that, okay, I get equation 3 is x plus 4z is equal to 14. I get equation 4 is -24x minus 4z is equal to a -60. I'm going to add these two equations together. I am going to end up with a -23x is equal to a negative, let's see, when I subtract this, I'm going to get 46. I'm going to divide both sides by -23, and I get a 2. I get that my x is 2. Now, I'm not done with the system. I still need to find my z. I'm going to plug that into equation 4. I think that's going to be my easiest one. So I'm going to plug it into equation 4. And so 6 times 2 plus z equals 15. So I get 12 plus z equals 15. So my z is going to be a 3. Then, now that I've got my x and z, I want to plug into either equation 1 or 2, not 3, because there's no y in that. I'm trying to find y. So let's say I plug it into equation 1. Okay. So let's say that now I'm going to take these and I'm going to use these in equation 1. So equation 1 is going to be 2 times 2 minus y equals 5. So 4 minus y equals 5. So I'm going to end up with negative y equals 1, which means that y equals a negative 1. So remember, I want to write this answer as a point. So I'm going to start with my x, which is 2, my y, which is negative 1, and my z, which is 3. And that's the end of this video for our example.